So this is DZ1. We're going to talk about Open Supervised Device Protocol. We got a panel here. I'm going to introduce them first. There we go. Steve DeArruda. How about you say a couple words about yourself, since we didn't bore them. Not everybody knows everybody here. I know some of you go to these mini sessions, you sit down with 12 other people and they all talk like they've been in jail for the last 20 years together. So they all know each other, So anyway, so some of us don't know all of everybody here. So how about just a little bit?
Sure. Good morning. Steve here. I work for Business Protection Specialist. I've been on the consulting side for 10 years. Prior to that, I was sentenced to 23 years on the immigration side. On the dark side. On the dark side, yeah. That's how I came to be here today. So.
Scott?
Sure, my name is Scott Lindley. I'm the co-founder and general manager today of Farpointe Data. We're a manufacturer of readers and credentials for electronic access control. Prior to Farpointe Data, I was originally with Indala, one of the first digital RFID reader manufacturers, and then for a few years with Thayer Systems.
Dean?
Dean Forchas, the consultant relations manager, North America for HID. We too are a manufacturer of readers and credentials, printers, as well as other ancillary items.
Panels too.
Yes, I was just about to touch on that. Recently we acquired Mercury Security, which is a great addition to our organization with Mercury panels, and so we are still in piece parts. We do not sell an entire solution, but we continue to expand our portfolio.
Dave?
Good morning, I'm Dave Weinbach. I'm product manager at Linnell for Identity and Innovation. One of the reasons I'm here is that I was one of the people that worked on the original OSDP spec before it was handed over to CF, along with HID and Mercury. That was kind of the core group that came up with the idea. My claim to fame is, if you don't like the name, that's my fault. If you can't remember the right letter order. So, good morning, everyone.
Yeah, we're going to have to learn how to pronounce it. Is it Linnell S2?
Sure.
Or, Linnell S2? Or, where's the pause in that sentence? Yes. Yeah, Linnell's 2, comma. Yes, something like that. All right, so what we're going to do here is I'm going to do a little brief introduction to OSDP, and then we're going to have some questions. We're going to put just slides up here, which are just talking points, so it's only a small number of slides. And then we'll have a conversation with the panel. Just a show of hands, how many of you have had any interaction with OSDP to date? Ed chuckles. It's always a bad sign when Ed chuckles. Anyway, so that was about half of you, maybe a third, something. So there are folks who haven't seen it before. Okay. So let's see, what is OSDP? So this is a communications protocol. So by that I mean there's two devices. In the old days we would have said they're computers, now they're IoT or something. They are talking to each other. There's a communications path between them, and there are messages that go back and forth over this path. And both devices are active devices, and that is they send messages and receive messages and act on them. So that sort of, it's a protocol. It's used in access control system, PACSs. If you use the IEC, terms, it's an ACU, not a CP. It's the access control unit, what we would often call the panel. It goes between the panel and the reader. Reader's the peripheral device. This is an OSDP buzzword. And it's not necessarily a reader, really. It could be a thing that interacts with cards. It could be other kinds of devices. And sort of the general thing is it supports credentials. So OSDP is not about the card or the card format, or if you've got a mobile phone, or you've chipped your elbow so you can just hip check the door or whatever. It's not about the credential, it's about the device that interacts with the credential. And the point of this is to support controlling devices at a door. And sort of that's obvious to all of you, but when IT people or folks in other environments look at OSDP, they say certain things sort of out of the gate, kind of, why did you do 485? Who would do that? And it's like, have you ever heard of UL 297? Have you ever heard of all the safety issues around having equipment at a door? So to the physical security people, that's kind of obvious. You would look at those issues. But when folks from other worlds look at it, they don't necessarily think about that. So for the background, so what we're doing now is considered OSDP version 2, I guess. So there was a team of vendors that put together OSDP, how long ago, Dave?
2007 or 8.
So 11 years now, 10 years. That evolved for a while, and at a certain point, they handed off the protocol to the Security Industry Association, which put it on a track to become a standard. And there's been a SIA working group for several years. It's a Security Industry Association project, but you don't have to be a SIA member to participate. And it's set up as a standards organization, so you don't have to apply, you don't have to pay a $50,000 fee to get into the committee. It's meant to be open for any vendor or anybody who wanted to participate. We could have end users. I guess in theory we don't normally have end users on that committee, but that kind of thing. And it's supposed to be, it was originally designed to support 485, RS-485, half duplex communication. So this is 2 wires, bidirectional, 2 wires and a ground. So it's, which is RS-485, again, from an IT background. This is a very old protocol. It was developed around the time the RS-232 serial communications was developed. Unlike RS-232, nobody ever defined the connector shell or the names of the signals. So it's a little arcane in that way. And it's designed for multi-drop. So there are some environments people put multiple readers on a single panel on 1 wire. The other environments, they do 1-to-1. But the protocol, the technology, the low-level technology in the protocol can support multiple devices. And the idea is it's supplying support for complex credentials. So in the Wiegand days, you ran a wire through the wall and it spat out a 26-bit number, which was 26 bits because we only trusted 24 of them and they had to have parity. And sort of that was the original spec. And in modern times, we've got devices that require communications back and forth, like PIV cards. We have credentials which have very large numbers, number of bits in the message with a credential number. So OSDP is able to facilitate this kind of stuff, biometrics, various other things. And like I said, it's a standards, it's a working group within SIA, and then SIA is a standards development organization that feeds into ANSI and IEC and some of these other international standards. So it's on track to become an actual standard with a number on it so you can specify it. So let's see, features. So you get multiple credential formats. It's not just one kind of card. Typically it'd be up to 1,100 kilo, yeah, I said 1K bits. I meant to say 1K bytes. There we go, typo on my slide, sorry. And it's able to handle challenge response, bidirectional communications with the credential. And everything's going over the data connection, all the signaling. So one of the issues we run into is I talked to a terrified integrator or security practitioner who can't find the LED power wire going out to their OSDP reader, and they think the world is broken. And it's like, no, dude, it's a message. We send a message down to the reader and ask it to light the LED. So this is the concept of control signaling over the data connection, and it has a secure channel capability, so you can do encrypted communications. It uses AES, 128-bit AES in a certain format, which is fairly secure. There's more work going on later to put it over a network environment, so you could use transport layer security, TLS, if you really need more. And you get conventional readers, door control things. It can activate or energize a relay to unlock a door, stuff like that. It can handle biometrics, so all the various kinds of devices you would put at a door. And like I said, with multi-drop, people can have more than one reader on a connection. Some environments do that, some don't. Sometimes it's a licensing issue, sometimes it's a technology issue. But the protocol can handle that kind of stuff. And this really is an IoT kind of a thing. It's a thing. So there's an active device at the other end of the wire. It's running communications protocols. There's highly likely to be a processor inside there running some kind of software. So the thing at the far end is not a dumb box. And then, so the current state of it, SIA has a forum mechanism. It's called SIA 360, and the committee participates in that, and people can get a login to that. So you can log in, you can look at the discussions going on, you can get copies of the current documents. So this is trying to facilitate communications not just with the people who would show up to the committee meetings, but for other folks. I mean, we have various reasons you might not be on the committee directly. It's in the wrong time zone. We have one developer in Dubai that interacts. Some vendors are very shy about their engineering teams being visible to other folks. They seem to have the myth that, if an engineer's head pops up, they'll be swooped in and, somebody else will hire them in 5 minutes, which doesn't really happen that way necessarily, but people are shy about that stuff. So there's the SIA 360 mechanism is there so that folks can participate at various levels, if whatever they want. There's the 6,000 people inside HID who only show a little bit of a signal, but, we can tell there's a whole bunch of them watching this. It's been submitted to become an IEC standard, the International Electrotechnical Commission, which defines power plugs. I didn't realize until we went to the IEC meetings that this connector on the end of my Dell cable, the Mickey Mouse power cable, that's actually an IEC Class 3 connector. There's actually a spec for that. And it's just to give you the numbers. I rattle this off and it sounds like I'm trying to give you some kind of FUD, but there's technical committees. So Technical Committee 79 covers access control systems, and then this is Working Group 11. Don't ask me why, but there's an 11 and a 12, and there's no number before that now. So this is Working Group 11, and the document number is 60839-11-5. And if you were trying to use that as a specification, that has just been submitted last Friday to become an official standard, and the voting sequence and all that is starting now. I would encourage you all to look at the 60839 series. -11-1 is the IEC description of access control. And when I read that, I'm the software guy, so my version is, I came over from the dark side, IT, about 10 years ago into the physical security world. So to me, this stuff all looks reasonable. My physical security practitioner trading partners, when they look at the -1 document, they don't all think it looks normal. So you should read -1, your head might explode, be a little careful. So their definition of alarms and what should happen at the console and things like that, it might not line up with an American view, but you probably ought to keep track of this. The usual companies are participating in this, Johnson Controls and Gallagher and Assa Abloy and various other folks. So it's the vendors you all know and love are already participating in this. It's usually out in the non-US market. There's a lot of implementations of OSDP out there now. Last time I did a survey, which was a year ago, there was like 50 in Europe and probably at least 20 in the US. And because it's a standard, there's no reason to go register it. So, I may or may not have, and the people in the committee, I did the open source version, so I tend to talk to lots of developers. We may or may not have ever interacted with a vendor who's done this stuff. If they read the standard and they properly tested for interoperation with other equipment, then that's fine. So that, there could be all sorts of vendors out there. And in the OSDP world, we're doing both 485 and network. So there's people doing OSDP over TCP/IP directly, where they use secure channel for the communications. And there's people doing OSDP over TLS, where they use transport layer security for the communications. So there's both that kind of network stuff. This means you'd have a network drop at the door. In fact, you'd have a network drop on the insecure side of the door. So when you think about that, you want to be careful. I said Ethernet and TCP/IP. I did not say take the company's network and put it on the insecure side of the door. I know all you wise consultants would advise people not to do that. We're talking electrical standards and protocols here. So anyway, that's the, sure.
On the IP protocol, can we do multiple drops off the same leg, or do we have to do individual IP?
It relies on whatever your network environment is. So normally they would have one drop per switch drop. But in some enterprises, they just assume that IP is ubiquitous, and if you needed 5 drops at the door, they'd run 5 wires, or they'd put a switch out there or something. So it's all the conventional IP rules apply. All right, so let's get to discussion here. So put up a few questions here. I wanted to get folks commenting on it. So OSDP in the marketplace. So first of all, what's the status of it? Let's start at your end, Dave, since you have all the history here.
So it's obviously been a long history, and it's taken a while to get people to the point of actually understanding in the community, in the customer community, and in the VAR community, understanding what OSDP does for them. And so I think we kind of reached critical mass a couple years ago when the OSDP version 2 standard became available with encryption. I think that was what pushed it over the edge and provided a very tangible value prop as opposed to Wiegand. I think before that, there's savings on wiring that Rodney mentioned. So there's a lot of benefits to OSDP, but I don't think that it was enough to make it worthwhile for people to even think about something different. Now it clearly is with encryption. So in the last couple of years, from a Linnell standpoint, we've seen a lot of uptake of the OSDP protocol at larger customers who want to get that encryption and have a fully end-to-end encrypted solution. I mean, they've been thinking about an encryption between card and reader for decades, yet they had an unsecured connection outside the secure perimeter. You know, the irony of that was, in my view, pretty striking, and that's what really drove us to work on OSDP initially. So right now, I think it's really up to us in the community to educate the VARs, actually, or to put it in specs that drives the security deployment. And there's no reason not to. It's just inertia, essentially, has held the world back from really adopting this and really getting that perimeter, outside the perimeter security. So probably 15, 20% maybe of our current new installs are OSDP. Really, that should be 60 or 70% or more. There's not a whole lot of reason to use Wiegand anymore, because OSDP saves everybody money on wiring, because you can use 4-conductor cable, as Rodney mentioned, instead of 6 or 7-conductor cable to get full functionality. And that's aside from the security benefits and convenience benefits, which I think we'll get into.
Is that mic on?
I don't think so, but I didn't feel like figuring out how to work that.
And we have to be careful with the mic.
How about this?
Yeah, that's great.
So the status from our standpoint, HID, we had the easy part of it. We just had to create a reader that supported the standard. And then the real work began, and that's outside of the HID realm. The next step, the panels obviously have to support OSDP. As Rodney mentioned, it's a protocol running over 485-like wiring, dual twisted pair. So you need that. And even if you have panels that support that type of wiring, the feature set needs to be exposed through the software. So it may have been on one of the slides, all of the LED and beeper control and all those types of things, and Rodney already did mention that the lack of an LED wire was concerning to some installers. It all becomes message-based, which is controlled by the system, which is wonderful, but if you don't have that software feature exposed on the screen, that feature doesn't exist.
Yeah, we hit the issue that you have to have the PACS be aware it's using OSDP, and you have to have the panel be aware it's using it, and you actually have to use all these features. So, you know, that widget you've been buying for 200 years that, you know, ran the beeper that was a second board, we kind of don't want to do that anymore if we're trying to run all the signaling through it. And you need to have the, you know, so like it's wonderful that Mercury panels support it. If the Mercury partners would all actually read the spec and use the Mercury API to get to it, it would be actually helpful also. I mean, some people do, Linnell, but we're still getting, we're still on the adoption curve. So getting all the rest of the people in the chain to support it is still a little bit of a challenge.
Exactly. So those are a couple pitfalls to be aware of. When you're speccing a new system, as Dave mentioned, there's no reason to be speccing Wiegand. Like 125 kilohertz procs, great technology in its day. It has run its course, and since virtually there's savings and the down the road benefits for OSDP that have yet to be realized, you're doing your clients a disservice in a brand new installation if you're speccing Wiegand and 125 kilohertz. So I put those in the same category as kind of yesterday's news, and OSDP with smart card technology is really the way to go for anything moving forward.
Sure, thank you. What's our status? OSDP.
Can I buy OSDP from you today?
You can buy OSDP from us today. Echoing some of Dean's comments, we've found that some of our integration partners aren't entirely ready. We had an example, I think about 6 months ago, where one of our partners called us and said, you know, we're using your OSDP reader. We can get the LED on, the LED won't turn off. We went through, worked with them, our engineers were involved. We found out that they were not sending a command to turn the LED off. So there's a learning curve, not just from the reader manufacturer side, but also from the integration partner side. The other point, yeah, Mike.
Is that a
Got a mic here. Thank you.
mic for Mike?
Is that an indication that they don't have the feature sets correct, as you were mentioning?
They didn't have the feature set completely worked out.
Okay.
And that's, you know, there's more to this than, say, putting a simple Wiegand
Yeah.
interface on a panel.
There are manufacturers in the room, so I'll be kind about this, but some engineering teams in the physical security community are not practiced at using standards and reading specs like that. So we hit artifacts where we find out, oh, some engineering team somewhere read the spec that they got 4 years ago because they're not keeping up, and they went and implemented what they thought was in the spec, and they never asked anybody else what's going on. So you end up with these artifacts hitting the field, and you go back and say, why didn't you do the LED off command? And they go, well, we didn't see that. And it's like, well, did you ever talk to anybody else about it? Because the other thing about having a standards-based protocol is we're assuming people are trying to be interoperable with multiple devices. So if you put OSDP in your panel, I assume you're going to go to Farpointe and HID and 12 other people and get readers and make sure this stuff all works across the multiple partners to make sure you've got all the features exercised. So the conversation I run into a little bit, I'm kind of shocked at this, is that, did you read the whole spec? There's a committee, you can go to the meetings, you can get online, that kind of stuff. So that, can you do LED on and off? And another one I found is that, they thought there was no alarm input because they hadn't read the section where there's digital input and digital output in the spec. Said, oh, I can't get the alarms back to the panel. It's like, yes, you can. And you need to read the whole spec and actually implement it. And if you take the mic, we'll go into feedback. I think we had another question back there.
Yeah, another question.
Yeah, is there a setup page for the readers to, like a checkbox to say, turn the light on, turn the buzzer on? How is that setup accomplished in like Linnell?
So Linnell worked with Mercury a long time ago to make OSDP as transparent as possible. In fact, there's just two controls that are added to it, like what we previously would have had for Wiegand. The only additional controls are you tell it it's OSDP instead of Wiegand, and then you have the option of turning on the secure channel encryption. Other than that, there is no difference, and you can mix OSDP and Wiegand readers on the same system, get the same LED behavior, assuming the problem we have run into is people didn't have their Wiegand readers wired correctly and thought we were trying to do one thing with the LEDs when in fact we were doing something else. But there is very little setup, so I think it's important to clearly communicate the fact that the design intent, which I think was very well realized, at least in the Linnell system, of OSDP was to make it as close to transparent to the VAR, to the installer, as possible, as opposed to Wiegand. And we made some compromises in the process to make sure that it would work, for example, on existing wiring. So you can use existing Wiegand wiring if you follow the spec. And we control LEDs in a way that's very similar, and in the OnGuard system, it's transparent. So there's basically, you say I'm using an OSDP reader. The reader sometimes has to be put into OSDP mode or ordered with the OSDP version. There's lots of cool things going on right now. We're adding capabilities to configure readers through OSDP, and this is a work in progress. It's not available in the market from Linnell today directly, although there's some ways to do it. You can use OSDP to control readers, to download configuration, to download encryption keys. So the goal here, working with HID and other reader manufacturers, is to get to the point where config cards are a thing of the past. And you just buy an off-the-shelf reader, hook it up. There's already auto negotiation, so people don't need to worry about baud rates and things like that. I think with the Linnell system and with my experience, it's extremely seamless and effectively identical to hooking up a Wiegand reader. You just need fewer wires. And I think after installing 2 readers, your VARs won't know the difference, and everybody would save money. So I think it's important not to belabor the point of features without saying that these are all features that you essentially get automatically by hooking up an OSDP reader, by and large. So there's not a lot of configuration.
Also, the various vendors have tools to to support validating your readers are working. So an example in the Mercury world, in their installation assistant utility, I believe they call it, there's a capability in there to blink the LEDs and make sure they worked, and run the buzzer and make sure it worked. So there's ways to configure it in the PACSs, and then how to validate it if you have deployment challenges. We had a couple of questions.
So let me finish with my question.
Sorry.
Is there what's the default then? Is the default a red-green on acceptance and a buzzer? Is the tamper switch automatically monitored?
So as far as LED color, the default is, with the way that OnGuard and Mercury work, the default is whatever the manufacturer of the PAC software decided the default would be with Wiegand is automatically also the default for OSDP. And I can't speak for other manufacturers. Honestly, I'm not sure I can speak for us. I think we use something that people generally don't like, which is like flashing red is normal. And that nice thing about this with OSDP is very easy to change, and it ripples through and changes your whole system. So you can make any colors. We just actually introduced blue LED control as well to OSDP from the Linnell Mercury side. So now, in addition to, basically you get a choice of colors: off, red, green, amber, and blue now, and you can make any state of the system any of those colors through a configuration file, and that is downloaded automatically. Okay. But the important thing is that it's whatever you had for Wiegand should be the same for OSDP. And then you asked the second question about tamper. That's really one of the other key benefits, probably maybe the key benefit of OSDP without encryption, because people sometimes say without encryption it's useless, it's nothing, don't do it. That's not true at all. You get a lot of functionality. You don't get necessarily more true security. You get some security through obscurity, but you really don't get security with OSDP without secure channel. You get a lot of functionality though. One thing that most people have never done is wiring two LEDs, both LEDs separately, which gives you a lot more control of LED state. Most people just wire the green because they don't want to buy the extra conductor. But if you control green and red, then you have, 8 states that you can create.
And with OSDP, tamper is another message. It's not another wire. So you cannot fail to wire the tamper wire. The reader will definitely send a tamper signal. Now, you still have to configure everything on the back side. So if my HID reader says tamper, I still have to go do the right thing in Linnell, for example, to make sure a tamper alarm, alert, whatever you call that, does the right thing.
But with OnGuard, tamper is on by default, and that was the no-brainer benefit of OSDP from day one, because nobody wants to do tamper because of the wiring inconvenience.
The other thing, there's a slight subtlety about the LEDs that reader vendors sort of check me on this. The general thing is that the reader will ship with some kind of LED configuration in it, because you power it up, it does whatever it does. Your reader might just blink red or not. It is the responsibility of the PACS to send the commands it wants down to the reader to do whatever LED configuration is necessary. So you get a little bit of a subtlety there. It's like if the PACS never sent any LED commands down to the reader, then you're going to get whatever the reader vendors ship you. So if Scott decides we should have blinking green all the time, that's what you're going to get until the rest of the system tells it to do something. So I mean that's sort of and a couple other questions. This guy.
Use the mic when you ask the question, because then it's recorded.
Okay, so what I'm hearing is that the protocol is there. My question is practicality and deployment. So the biggest issues that I've experienced, and I don't have any recent that we've actually gone through the actual implementation. They're all in spec stage still, but the experiences I've had with implementation have not been pretty. So there's another element to this that I think we all need to understand as consultants, and I think even as manufacturers from both ends, you need to understand it as well. It's all great that we can do all this stuff, but it has to be enabled appropriately. So that means we have to now specify it. But also there's features that don't always jive with OSDP. For example, I remember on one project we actually were getting we kept getting communication failures because the reader went into sleep mode. And so now we have a reader that's designed to go into sleep mode. It's an energy efficient reader, and now I get OSDP communication errors constantly. So there's things that we as consultants and specifiers and people who are actually testing these systems out, because the last thing we need to do is to figure out oh, by the way, it's broken now, how do we go fix it? It may be an easy fix, but another problem we've had has been the concept of who's responsible. You know, I heard already, okay, well, we found out that it turned out to be on the manufacturer side of the software, not on the reader. But the reality is that I usually, when I'm dealing with these issues, get finger pointing from both sides.
So this goes back to the loaded comment that it's a communications protocol. So when I said that, you didn't hear the 35 years worth of network troubleshooting in my voice. So to give you some examples, and we've hit this with some vendors fairly recently, if it's a communication protocol, there should be some trace capability. So if Ed calls me from some job site and says the thing doesn't work, my first answer is, so go to the PAX vendor, turn on tracing, get a trace, and send me the trace. I'll be happy to help you, sir. So you need capabilities like tracing, and you need capabilities like keeping track of error conditions. So another thing from the communications world that hadn't been done traditionally in the PAX world is if you have line errors, you should keep track of those. So in the OSDP message format, there's an error correction capability, and there's the concept of message retries. But you can't get that counter out of some people's panels. So there should be some sort of communication statistics capability in the products. And so when the integrator says doesn't work, the first question is, did you look at the link statistics to make sure your wire wasn't mangled? And the second question is, did you get a network trace and get the manufacturer to help you analyze the trace to see if there's anything questionable going on in that? And so those, from the networking side, from the IT world, that was, get a trace, go look at the network, and then troubleshoot from there. So we're still kind of missing some tools. So, I'll call Scott and I'll say, reader doesn't work. And he's going to say, well, what did you send the reader? Or, is the wire to the reader okay? I mean, there's a bunch of questions you would get. And I get the troubleshooting gig. So I get to unwind the finger pointing thing. I've some practice with that. This is an example of you to go through that.
I just want to respond a little bit to that also. So a lot of your comments are absolutely things that we've seen in the real world, and Dean's shaking his head, yes, right? Right. To the extent, we're going from a very low market penetration to a mainstream product, and that's just really happened in 2017 and 2018. So we are seeing some teething pains, and so Rodney's points are valid that we need those tools in order for the manufacturers to troubleshoot. But I do want to reiterate the fact that a properly designed and tested system, not something that you guys designed, but meaning that Linnell and HID designed, shouldn't need any of that. And this really is a functional replacement to Wiegand. And it shouldn't be any harder, and it isn't any harder to hook up than Wiegand. Now like I said, there are things that haven't gone right with people ordering the wrong reader configuration, not already working on OSDP, sleep mode. I mean, there's no excuse for that, right? If you're making an OSDP reader, so that's a teething pain on the part of that reader manufacturer. We've all had issues with new products. It's just what happens. A lot of those are water under the bridge. Some are still happening. But the important thing is that when you order the right part that is configured properly and you hook it up to the panel, it should just work. There's no, I'm a little concerned about the sense that's coming across that there's some configuration or setup or anything like that. There isn't any. You hook up the reader to the panel, and a properly designed system, you'd say it's an OSDP reader just like you would have previously said, whether it was Wiegand or Magstripe. You already had to make that selection, and so it's not an additional selection, it's an additional choice, and then the thing just works. And so that's the design goal. One thing that Linnell is doing to help address some of those specific things that you're talking about and that have been talked about already is we're just spinning up a new part of our certification program for third-party products specifically for OSDP. And so OSDP readers will be certified by Linnell as being OnGuard compatible. And it's specifically to address those kinds of issues where do we have a document that gives the VAR the correct tested steps to configure a reader for OSDP, for example. So we are trying to address it on the process side. The technology is already there in terms of making sure it's plug and play, and that's really the intent.
Well, and don't get me wrong, my perspective is not that I'm against OSDP. It's that there's a lot of people here who are going to be very quickly frustrated, as my client was the last time I tried to deal with this end. And what I'm trying to do is to avoid the circumstance where, and help wherever I can to avoid the circumstance where we have customers that don't want to deploy because they don't have confidence.
Sure.
So to me, it's a lot more than, Wiegand sucks. It's always sucked. It's been sucking for as long as I've been in the industry. So.
Friends don't like friends use Wiegand. Yes, I know. Yeah.
And
I just want to make sure that what we replace it with works.
Yeah, we need to have successful deployments.
Right. Yeah, and one other point though to your, so what is there, we can't ignore what is the way to ensure a successful deployment of anything in any industry? Exactly. So if you buy 2 OSDP readers and a panel and tell the VAR, if the VAR buys it and says, okay, show me this before we go, show me it working, he'll work through all of the issues, and then when he goes on, it's done deal. Tell him document it. You want to see the one-page document of how to set up a HID reader with Linnell in OSDP mode with secure channel. And they get it from us, they get it from HID, or they create it themselves. Then that work's done.
Yeah, just echoing Charles, the experiences that you've had early on, I think as Dave put it, teething pain. It was very easy. I'll just, take a little hit here. Our tech support department said we support the spec. We've tested against the spec. It's got to be the panel manufacturer, Go talk to them. And lo and behold, it turned out to be a timing issue on our side. So we've learned our lessons. We probably have still lessons to learn. But as part of this answer of what's the status, we have thousands of OSDP readers deployed. So it isn't like this is bleeding edge. So I don't know how far back some of your issues go, but we keep getting better.
It was early, but that's what I'm saying. I'm just more curious, not about bringing up the past as much as let's resolve the past, right?
Sure.
There are teething pains. This is a new technology.
So this is
it's a new deployment.
Yep.
Let's make sure it's right. And one of the things as consultants, the guys that haven't experienced the pain, I want to make sure that they know.
And that's why we're all here trying to help each other. Yes. We had some other questions, Brian.
I'm just curious, in your experience deploying these in retrofit applications where you might have garbage legacy wire out there, you don't necessarily have a beautiful twisted pair with a ground wire. Right. Someone's got a pair of wires out there, they want to use the shield as the ground. I mean, how sensitive have you found the OSDP protocol to the actual cabling? And you finding that, you're having errors and things like that?
It's a great question, and there's two answers. There's the official answer, which is OSDP requires a dual twisted pair. And before I get, too far down the road, I'm going to let Steve talk because Steve's gotten into the wiring aspect of this far more than I have. However, Wiegand as a limit in the spec was 500 feet. The reason for dual twisted pair was to eliminate crosstalk on long runs. In our environment with OSDP, 500 feet is not a long run. So although official answer is you need dual twisted pair, we have hundreds and hundreds of readers wired reusing the existing Wiegand wiring. Now, of course, if it's skin and it's shorting, that's an obvious thing. But what I have recommended consultants do, you're doing a retrofit, you have a building with 100 readers, tell your client, we're going to reuse that Wiegand wiring because it should never have been over 500 feet. And we're going to save you whatever it is, $50,000 of wiring poles. However, if we have one run, just covering your backside, if we have one run that's giving us crosstalk or is messing up, we'll pull that only. And they're going to love you for it, and you've got your easy out.
So the other piece of it is the OSDP environment. You could have run at different speeds. So now we're back to laws of physics and serial communications. So if you run 100,000 baud over a 500-foot wire that was using the drain as the ground, it might get kind of sketchy. If you ran it at 9,600 baud, then it might run just fine. And so the protocol can support these different capabilities, and we hopefully have all done our job together. So like when a Linnell system auto-negotiates, or perhaps you might, in some cases, provide specific parameters to support dealing with that. So there are ways of dealing with it. Also, because the protocol's got error correction, if you, God forbid, did this and didn't figure it out from the crosstalk, look, crosstalk is, I mean, we can talk about crosstalk, but how is the integrator in the field going to check that? Where they'll whip out their oscilloscopes? But there are facilities in the protocol to support people trying to identify these challenges during a deployment.
Sure. So for us, for me as a consultant, this was a big topic for us, and I've known about the protocol for years. But the time to look at it was when I made the decision to say, all right, now's the time to move, was earlier this year when I attended the Mercury event back in March, and then I was at ISC West and speaking with Dean a lot about it and saying, all right, I'm hearing all this great talk about it, and when's the time? He's the one that says, now's the time to do it, because we've got secure channel now. So for us, I said, all right, I'm going to look at this as not running out to every client that we've ever worked with and ripping out all the Wiegand readers or, and saying this is the way you need to go, but instead saying, all right, where does this make sense to deploy? We've got a large client, hospital healthcare client down in one of the Carolinas, and they've got hundreds of readers that are Wiegand wired, and we've been going through this process for 2 or 3 years with them. They're building a cancer center. I explained the situation to the client, explained the benefits, why we want to do this, why we're looking at this technology now, and they said, yeah, let's do it for the cancer center. So they're on their single campus, they're going to have one building or sets of buildings that are wired all OSDP, and the others are going to remain on Wiegand. And for me, I looked at it as, back years ago, NextWatch, anybody familiar with that? WSE, right? The DigiKey readers, right? Ed, I know from out there. I did a lot of that work, and we used the per spec OSDP, and it wasn't, the per spec RS485 wire, which is the low cap wire, very different configuration than what we're talking about. So at that point I said, well, you know what, to do this correctly, I need to stay within the true specifications of RS485 with the low cap wire. So I started looking at solutions for that. Started working with Windy City Wire, another manufacturer, to say, what can you do with something that you've got on the shelf now? If you look back then, and even if for anybody's software house out there, if you look at what they recommend for wiring between their i8s and 08s, it's also low cap RS485 wire. Look up the Belden part number. You'll see what it is. It's a very different cable. So knowing that, looking at that, saying, okay, maybe this could work, but to the letter of the spec, I think that it's probably a good responsibility as a consultant to say, I think I need to go to the next level with this and use the cable that's actually meeting the RS485 specification. And that's when I approached Windy City Wire to say, this is what I'm looking for. I mean, I've been a proponent of composite cabling ever since the stuff came out. But trying to get the dealers to do that, people I worked for, ownership, it was expensive, it was this, we don't want to do that, we don't spend the money. Well, I can't, it's in every one of our specifications, composite cable, have to use composite cable. So to still push that, but then go backwards to allow individual elements didn't really make a lot of sense either. Again, go back to the drawing board and say, okay, what can we do? Let's build a cable that satisfies all the needs. And knowing that the 500-foot limitation was now no longer there, what's the next limitation going to be? Power. Okay, we're going to have voltage drop on the other end of that wire. So I said, well, we're in a good place to do this. Why not put something else in there? How about an 18.2? I did some calculations with that and looked at where that could take us, and it was pretty much at 1,000 feet was going to be no problem. Looking at power draws for the HID readers based on 22 gauge, kind of transposing that in, looking at it, kind of reverse engineering it back and saying, okay, 18.2 is probably a real good choice and get us past that. Now, 1,000 feet, yeah, that's a long haul, but with an 18.2, that's something that's common to everybody. It's out there, it exists. Why not just take what we've got on the shelf, bundle it up, and make it work? So one of the other driving factors for me, once we've got the secure channel piece in place, and I said, you know what, as a consultant, we're supposed to be recommending to our clients sort of the, we're supposed to look out for their best interests. They're paying us to look out for their best interests and to protect them and protect their systems. So I thought, well, God forbid any client of mine ever come back to me and say, well, why aren't you using this OSDP with a secure channel? We all know our clients are educated. They go to the trade shows. They hear all the buzzwords. They want to know what's going on. They want the latest and greatest, but they also want the protection. So I felt that for us to be in a position where a client would come back to us and say, why didn't you do this when you knew about it, to me is a disservice to our client. So that was the other driving force behind it. We educated ourselves on it. We now know where we want to go with it. I understand there are going to be bumps and hiccups in the road, but why not require a test system? You know, if you've got this one I just mentioned, we're going to require a test system be set up, test the LED functionality, test all the reader tampers, all those things, and make sure we've got it working in a test bed before we drop 130 readers on the floor. So those are some of the things that, from a consulting side, we were considering.
So one comment about the test system. Are you going to do that, require 1,000 feet of wire on the spool next to the panel? Make sure it works. A lot of crosstalk. The question I had was about the multi-drop. You know, the bane of the industry has been in-out readers because it always requires a second run. Can we truly get in-out readers off of a single OSDP drop and be able to identify this person, you know, carded out, this person carded in, you know, maybe there's piggybacking involved, et cetera. So can we get that kind of information out of it?
Yes, you can get that information out of it.
That's an easy answer.
So yes, for multi-drop, there is the deployment issue that, like a 485 device, there's addressing on the readers. So there is the scenario of we have a string of 50 readers on one wire, you power them all up, which one's which? So in HID's case, we have a mechanism to be able to attach to the reader with a handheld app and say, you're the front door, you're the back door, so that we can distinguish them. But that was one of the real world deployment issues, since there's no little wheel on the back for those of you who are familiar with addressing the old 485 or RS-22 devices. There's no such thing. It's done in software. And so you have two choices. Either use some third-party app for addressing, or you bring your readers up one at a time, and as they come alive, you have to. So I'm going to let you talk about how
there is
you do
another choice coming down the road, which is dynamic addressing, which there are customers asking for that, where we add where the protocol is going to get enhanced, so that so if you put 50 readers on one single wire, that there's now a mechanism where they can sort that out, and it can be controlled from the packs. Yeah, it's like DHCP. That's a work in progress, and the standards. It's not done in cast in concrete. It's a living document. And so that's actually the next work item, is to add enough dynamic addressing to add to the capabilities you talk about. So then you can figure out which is the in and the outdoor.
And when we first developed OSDP, we had some decisions to make, because RS-45 is 4,000 feet multi-drop, and you can do full or half duplex. And all of the decisions that Linnell, HID, and Mercury made were basically to make the system as seamless and as Wiegand-like as possible to install. So we didn't do addressing at all. We said everything should be address 0. We limited it to 500 feet to give a lot more. We basically derated the risk of cabling issues by saying instead of 4,000 feet. And also, honestly, not using multi-drop also makes the cable less sensitive, because multi-drop introduces a whole new set of issues with cabling. RS-45 is a very carefully tuned system, and even in a carefully tuned RS-45 system, and I've done this in other industries, if you have 4,000 feet of RS-45, man, you're good. That's not an easy thing to do. So we made some decisions to back away from all the theoretical capabilities to ensure that when a VAR went to install it, it was just like Wiegand. What we're recommending today for multi-drop is exactly what you said. We recommend it for in and outdoors. There are ways to do it across multiple doors, but VARs, again, are used to a one-to-one, point-to-point. This is my controller, this is my door, this is a reader, and we wanted to not create culture shock here and make it hard and scary. We want to make it simple and easy. So we've gotten to the point where a lot of VARs now are comfortable with deploying OSDP as a Wiegand emulation with additional functionality. Now they're ready to start going a little farther. So the baby step that we're taking is let's do in and out readers. But you still do have to address the readers, and that does add a level of complexity and risk.
And again, the addressing is a signal thing. It's a part of the message. It's not, the lower left plug on the Mercury board is address 0, and the plug above that is address 1. It doesn't work that way.
Personally, I would never see 50 readers on a single point, because the most critical point now is panel to first reader, right. And you've dropped everything if you lose it. Can you run what we call the fire alarm business Class A? Can you secure that loop so we have bi-directional communication? So just this Class B run, basically, that you can't go back to the panel and create a bi-directional
Create a loop? No, not currently.
It's not multiple paths.
fire alarm we can.
Question back here?
I have a clarification, 2 questions. Clarification, a couple times you mentioned dual twisted pair. And when you originally started out, we said it was a single twisted pair. So is it a single twisted pair or a dual twisted pair?
All right, just for that is 3. No, I'm just kidding. A pair for signal, and
pair for power.
and then whatever you need for power, like Steve was mentioning. Power is another factor to consider, and it depends on length of run. Reader power consumption varies very widely. I mean, we have 60 milliamp readers, and we have 1,000 milliamp readers.
Okay, well, that's what I needed the clarification.
Yeah. So
Next question is, since we're doing a lot more control and function out at the reader, are you looking at the potential for adding remote I/O capabilities on the readers so we could drive other things through the serial connection and open door or turn strobes on or things like that?
Well, yeah, Rodney actually mentioned it is part of the spec. And so that's something that reader manufacturers have the freedom to do. And there's a lot of cool things coming down the pike with OSDP. One thing we haven't mentioned is you have full LCD strings you can use as well. So you can send messaging to readers, you can have pin pad control, function keys. There's a whole lot more that could be done because it is a true communication protocol. Whereas Wiegand, you needed a wire for each new feature, and this isn't the case there.
The other thing is you don't want to get in the trap where the device on the outside is controlling the relays. You do not live in a Stargate Atlantis universe where some guy named Rodney is going to pull the reader off the wall and short a bunch of wires and make the door.
But I would only be using it for local enunciation lines, strobes, things like that.
So for appropriate uses, yeah.
And also from the fire alarm industry, I work for a manufacturer, so we're very familiar with 485 and addressing. I worked with the rollout of the MXL for the addressing. Do you have collision avoidance on this now for your bidirectional?
It's half duplex, so we don't need that.
There is in the spec, it describes what you're supposed to do to make sure that you don't have multiple devices talking at the same time, and there's the mechanism about how you start sending a message actually is to make sure you would not have to, because it's half duplex, you could have 2 talkers.
So when we started in the fire alarm industry, we had to program the device with an address. And then some manufacturers had a programming device to do that, and we eventually got to the panel where we could actually just enter the device addresses. Do you see that going forward as a potential? Because I think the addressing is a real key feature.
Rodney was saying that that's coming in the next spec.
Yeah, and you can, in the current version of the spec, a single device, you can command it to be set up at a specific address. That's the dynamic addressing mechanism.
And one last question. So do we have other manufacturers looking at auxiliary devices that will hang on this same protocol? Or is it just strictly going to be a reader?
Yeah, so for example, Cypress sells devices that are used as time clocks at General Motors. There are people doing things that are purely relay devices, relay control kinds of mechanisms, where there actually is no reader in the picture.
So the issue always has been everybody's been trying to use access control for time and attendance, and then we run into HR issues with time and attendance. Will this provide an enhancement to allow us to now use time and attendance since we have these features?
It's our understanding that it's fitting people's requirements for that. So the example, to use the Cypress example, in the spec today, we made sure the time format was well defined. And you have very strict rules in a auto industry union environment.
Yeah,
They've got a big clock on the wall.
Right,
you have to see the clock. They're not going to leave until it actually goes to 3 o'clock, 000, et cetera.
So with the LCD display, we could then reverse that and have a clock right there.
In our system, that's what it does by default. You can't even, when you hook up an OSDP reader, if it has an LCD, it shows the time.
Thank you.
So back on your cabling question. So I err on the side of caution with my designs. So I want to keep the power separate out of the same cable that the communication is going into. I don't want to take a chance of any crosstalk getting into that comm wire and having any kind of problems. So that's my choice, but these guys are saying, hey, twisted pair works. I don't want to take the chance,
I mean, we have the same issue in the IT world, and we're running, 4 pair with PoE over it,
right.
and we're not having that issue, that crosstalk issue. But isn't this a simpler solution, just 2 pair shielded and 2 pair non, and run your power as a composite cable?
It could be, yes. Again, I err on the side of caution with all our designs and make sure that we don't have that problem. I don't even put I don't even like putting power supplies in with our Mercury hardware. I keep all that separate because I don't want the 120 volts and the EMF that's generated from the spikes that come back off the strikes to even be in the same cabinet as the Mercury boards.
That's
So,
a whole different conversation.
absolutely, but I'm just saying, those are the things that I look at and say, this is why I chose the path of doing a separate power wire.
A question back here?
Well, I don't want my stuff out of the door, and then I got power supply issues, and drop and put it in the communications room, I got no more room.
A question back here?
For clarity, the OSDP specification or standard is from SIA, and we can go to SIA and get a copy of that?
You can get it from SIA today. Once it gets incorporated into the IEC mechanism, you'll be able to purchase the standard through the standard IEC standards publication mechanism.
And you mentioned OSDP 2. Should we be looking for 2, or are they interchangeable?
So
They're
there's a lot of different terminology. There's a lot of terminology being used, but really you just want the latest version of the OSDP standard. There is actually no, they switched the number, they counted up from in ones, and when they added encryption and a couple other things like biometrics, they went to 2.0 and 2.1 and 2.1 whatever. So there are not 2 different standards.
Okay.
There are just older and newer versions of the same standard.
so it's currently 2.1.7, and that'll change soon. That's the one you want right now. And there have been reports of old OSDP 1 systems reacting badly to OSDP 2 devices. I don't think that's a protocol issue. I think that's a unfortunate collision of implementations. Let's put it that way. There were other questions over here. Okay, we can. So we get first through. Let's see who's selling it. Market drivers. You were saying that is it only large enterprises using it? I mean, my view is that an integrator should have a bucket of 10,000 readers that they bought from Dean, sitting in the back room, and if they got one little building,
thinks so too.
One little building in downtown Palo Alto with 3 doors, you should still be able to use OSDP on that. That should totally make sense.
Yeah.
How many Linnell panels should they have?
That's right. An equal number.
Well, since it's all interoperable, I don't care.
Yeah. So no, it's not only large customers at all. I think the problem is that, as with some other things we've experienced lately, the VAR channel seems to be the thing dragging this down a little bit. And I didn't say that if anybody asks. But the manufacturers are fully up to speed and want OSDP to be the standard. The larger customers who are more tech savvy, who go to ISC West, are asking for it, and the VARs are complying. What's missing is the VAR initiative, in my opinion, to, even with a smaller customer, say, well, first of all, the obvious choice is to not say anything and just install OSDP readers. There's very little, if any, cost difference. There's very little, if any, wiring difference, and if there is, it's sometimes an advantage. So I think it's an educational obligation that we have not fully fulfilled to get the VAR community up to speed so that they use, basically at this point, given the experience in the industry with OSDP should be the default, and it should take a lot of arm twisting to install Wiegand. And I can't think what the twisting would be. I want to spend more on wiring. I want a less secure system. I don't want as good control. Please, please, please let me use something worse. I don't know what that is, but.
Doesn't this fall on the consultant, where if we specify OSDP, the VAR's stuck?
Yeah, absolutely. That's why we're talking to you. Yeah.
But you keep talking about the VAR. I don't care about the VAR.
Yeah, I know. So unfortunately, some jobs go without a consultant, right? And in those cases, the VARs aren't taking the initiative. That's from my perspective.
Well, I don't know about you guys, but with the VARs, they'll look at the spec, they'll look at the drawings, and they'll go, "Oh, you didn't really mean that." I mean,
That's what shop drawings are for.
I know, but
Get past the shop drawing.
well, hopefully, I found the way around that, and I've been tutored pretty well by the guy sitting next to me. Is you want to design at a level that they can't even argue with your drawings, and that's just into the case. But I mean, I've been asked for the last 20 years, you didn't really mean that in your spec. I'm like, it wouldn't go in if I didn't really mean it. So
I always ask them when they ask me that question, I said, well, if I missed the device, are you going to give it to me? And I'll tell you no, because you missed it. I said, well, then apparently you got to follow the documents because it hasn't missed it.
go on to the next. Let's see. Advantages. We talked about the cabling. The being able to change the amount of cabling you're doing. This is the thing that, like us IT people forget about. And it's like, in the IT world, you sit in the room with the CIO and they say, make a drop happen there. And it's like, I don't have to think about what it takes to get, run through that. But in the real world with construction issues and things, so the cabling side of this is a benefit, even if nothing else.
It's a serious benefit. I mean, on the signaling side, just to point that out, you brought up the issue of EMF. I think everybody's aware of errant signals in installations running through and messing with other signals and the likes. One of the real advantages here is if you're using an RS-45 chip or a serial chip in there, there's a lot of isolation that can occur with that, and how should I say, proper design. And what should I say? In the world of Wiegand, it's sort of a weird, everybody has their own little circuit and how they make it work. But if you look at RS-45 circuits, it's standard practice. There's reference designs. You can harden that circuit or that interface really to as hard as you want to get and be able to eliminate the effect of that EMF that may occur on that site. So in all practicality, you should see less issues with how should I say, site interference that's been a bit of a bane for our low voltage industry compared to the legacy protocols of Wiegand, Magstripe, things of that nature.
Yeah, on the signaling and features kind of stuff, there is one thing we haven't really talked about. So we talked about tamper briefly, and tamper is good, obviously, and useful when somebody pulls a reader off the wall, but that's not the #1 failure mode of readers, right? Readers fail for all different reasons. And Wiegand never tells you if a reader fails. It just sits there and everybody thinks it's fine, and then people get upset. Whereas OSDP is a pulled protocol. And so
the S stands for supervised.
Right, exactly. So the supervision aspect of it is really a very, very important benefit to every single reader in every single size system, whether or not you use encryption. The second that reader goes to sleep, you're going to get a message in your access control system saying that reader's no longer here. And if it loses power, if the power supply fails, if a fuse fails, if there's a short circuit in the wiring, all those things are signaled instantly. And that's a huge difference from Wiegand, night and day difference. And that alone should be enough reason to consider OSDP as the standard instead of Wiegand.
The other thing was, so people here using biometrics? We had the very interesting talk yesterday. So we didn't have a let's see. No, technically we don't have a biometrics reader vendor. Neither of you guys are selling biometrics.
Well,
no, you do, right? Yeah. So I mean, you can. This is an example. You can get biometrics with OSDP. So that can go through the system too. A lot of the biometric solutions out there, big fancy thing, knows how to recognize 55 million faces, has a Wiegand wire out the backside. So this is a steel door in a grass hut. So. Right, 26-bit Wiegand. Yes, right. Exactly.
So,
yes.
So now you got me started, because I haven't been talking up till now, but OSDP biometrics is really something amazing and game-changing that I think all you should think about for your customers that have biometrics, because biometrics has been the most proprietary, most high-risk technology that we use, and you're entirely reliant on a vendor. And if that vendor changes their product line, decides, hey, this other kind of template would be cooler, then all of a sudden your customer has to recapture thousands of templates. If the readers start failing, you're really stuck. Your customer is stuck. You got to keep buying from that manufacturer because they have a database full of templates. So what we've done with OSDP biometrics, and there's other ways to implement it, but what Linnell's done is we've created a completely standards-based biometric solution. And we use ANSI 378 templates, the same one that the federal government uses. We capture those into the OnGuard database, and we then use OSDP, and your customer can use any credential they already have. They can use their standard credential, whether it's Prox, iClass, Magstripe, barcode, PIN, doesn't matter. It's a token, looks that person up. The panel then uses OSDP to push the single biometric template for verification down to the reader. And you get a nice smooth transaction. It's card technology agnostic. It's card format agnostic. There's no encoding of cards. You can use our existing population base and just capture people into OnGuard, and it will just work. But the really huge benefit, in my view, is you're not locked in, your customer's not locked into a single manufacturer. So let's say you love Suprema biometric readers, you think they're slick and they're very cool looking, but they don't make an outdoor reader that meets your needs for your environment. So you go and you can get a Morpho outdoor reader, and those can interoperate seamlessly on the same system. Or you can also create you can create a competitive situation that's much more optimal for the procurement process, and say, we want an OSDP reader, biometric reader that has this temperature rating and this false accept and this false reject, end of story. You don't specify anything beyond that. And then the VAR can offer the best performance, best price, best service. So in my view, that's something that is really a game changer for a whole aspect of what we deal with in physical access control. Is, in my view, there's no reason anymore to spec a particular vendor's biometric solution. Now, I'm saying all this as one mode of operation, which is our standards-based mode of operation. There are, but OSDP isn't locked into that. If you want to do iris templates, if you want to do hand geometry or vein recognition, all those can be done. The OSDP system supports all of them, but what we found is resonates very well with the end user is the idea you're not locked into a single solution. And we all know the history, or a lot of us know the history, of biometric readers in this industry is very up and down, right? And every time there's a down, people get hurt. It's not just the manufacturer goes away, it's that you have these orphan systems. And so OSDP biometrics gets you out of this orphan system problem. And I will get off my soapbox for now.
So everything Dave talked about being a little bit vendor agnostic with the biometric side, in HID's case, we have something called a transparent mode, which is an attempt to become key agnostic. It's being used more on the government side to date. We just found out that the French government approved and certified the readers for their use in high secure facilities. And here's how it works. The way it typically works with the encryption keys, the reader and the card negotiate, and they have a key to be able to secure that transmission. In transparent mode, the reader just becomes an antenna, and the card spews some data, and the reader says, I have no idea what this is, and passes it up to whatever device is upstream, be it an access control panel or some other intelligent device that has the keys to decrypt, and says, oh, I know what that message is. Reader, please tell that card this, and sends a message back, and our reader says, I have no idea what this is, but the panel told me to tell you this. So we just become an intermediary, and for anyone who has tried to take over a system that has existing EV1 keys or I-class keys that you didn't have access to, you know what a nightmare that can be. If the device on the backside has this ability, those problems go away. So we're very excited about OSDP for some of those types of features.
So that feature that HID initiated and is patented on and stuff, the status these days is, it's patented, but it's what's called, I'm spacing on the term now. It's a very simple thing to go patent. It's a URL on your website. You read the page, you click yes. End of discussion. You can license it. Right. So it's available for other environments, and it's in the standard now. So it's codified, so people will properly implement that and use the messages you're describing, and of course we'd use it with HID, but it's available as part of the standard, so you can spec it, and it's nice and stable and well documented.
Do you think this is going to have any impact on the FIPS?
This
is used for FIPS. You mean PIV or you mean FIPS?
FIPS 201.
FIPS 201 is PIV. Okay, so FIPS 201 standard is a federal standard which describes a badging mechanism that was originally done for the federal government, but PIV is now a Kleenex word. It's a description of how a smart card interacts with the system it's behind. This is uses to facilitate FIPS 201.
But
but I'm thinking, is the feds going to get away from the FIPS and?
No, it's the opposite.
This is how they do it.
Yeah, we all.
Use the pan.
Yes, exactly. Yeah. Correct. So the panels that we offer have the PAM code. It's actually HID PAM code running on them, and they use OSDP transparent mode. And it provides the exact benefits I just talked about with biometrics. As Dean said, it also provides in other areas, because now the customer has a choice of reader manufacturers. If they support PIV transparent mode over OSDP, then our panel can talk to them, they can talk to the cards, and you can again mix and match reader manufacturers and have that competitive environment versus a proprietary environment.
All right, let's see. We're doing good on burning up the time. We have like 5 minutes left. So we kind of talked about this already. What are the challenges in this? So we went through a laundry list. Just add a couple of things myself. So after you spec it, and after you make sure that the documentation that went to the integrator means they actually have to read the spec, we still need to have them have the person at the other end who's wiring the reader actually follow the instructions, because Wiegand has been around long enough that some people are wiring readers through muscle memory. They don't look at the paperwork, they don't ask for the paperwork, they roll a truck, they go out there, do the thing, and then they call us and say it doesn't work, and we go, somebody goes and looks at the wires, and it's very proudly wired up to the back of the HID reader on the Wiegand pins, not the other pins. So we actually have to push this, we have to communicate all the way through the system that what we wanted them to do. So we're getting challenges of that sort. The other thing is the subtleties about the cabling. You need to run enough conductors out to the door, which some people apparently don't necessarily count it correctly, which I would think would be really painful to figure out after you've already pulled the wire in the wall. So let's see, what else? Secure channel. There's a mechanism. There are AES keys. So then now we have the tension of how do we do the InfoSec way of looking at it. So Dave wants to give you a single button that says do secure channel, and I, the InfoSec auditor, want to know what keys are in my panel because the customer says they need to control them. So I don't want an easy button. I want a load to key button. And so we're going through this process of identifying. And I mean, I didn't make that up. I'm just the messenger dude. So there are certain places where the customers have a requirement to look at it that way. So in some cases, they're going to want a more advanced way to configure it. And no, my 3-door building in Palo Alto, I'm not trying to go crazy with the key loading and all that. But my hospital environment where I have to deal with the HIPAA auditors, maybe I do. So there probably are going to be more evolutions of this kind of stuff. And that's not a reader thing. That's the PACs and the panel have to control this. So are we all doing secure channel, A, securely, and B, the way the customer wanted it? Are we all meeting the customer requirements? That's another kind of a challenge. Any others?
Well, actually, to address some of those challenges, there's a concept that we maybe touched on briefly, but it's worth highlighting. The panel and the reader have, and you probably know the exact term, a compatibility table, if you will. So the panel has the ability to inquire from the reader, what are you? What capabilities do you have? For instance, if you have a blue LED, great, I can turn on a blue LED, but to send a signal to a reader that has no blue LED, to turn on the blue LED, of course, it's meaningless. So these secure channel, non-secure channel conversations that we're having, those fall into that compatibility. So as your clients and your end users, consumers of OSDP, upgrade panels, maybe the panels today don't support secure channel, but you replace it with a secure channel head end, and all of a sudden they say, oh, you got secure channel now. We'll turn on and we'll use that feature. So a lot of this is being done on the fly, if you will, as part of the negotiation when the reader starts up. Yeah, so that's really good news for all of us from an upgrade standpoint.
Yeah, the OSDP buzzword is capabilities. There's you request the reader's capabilities. It comes back and tells you, do I have a buzzer? Do I have a bicolor LED or something more complicated? Do I do secure channel? Do I do smart card support? Do I do secure pin entry? A few other kind of parameters there. So it's kind of like plug and play, where the head end equipment can inquire from the device what its capabilities are and then tune its behavior based on that.
Sure, I'll toss out another challenge. This is a real world challenge we're facing right now with a project. We're working with a nationwide fast food retailer. They have thousands of sites, I think, through the United States, small. They currently have an access control system in use in their sites that is not OSDP compliant. and they're looking for OSDP compliant readers such that they know the status, preparing for IoT, and such that they know the status of those readers on site. So one of the challenges they have is how do they upgrade their existing infrastructure to support OSDP-based readers while maintaining their non-OSD compliant access infrastructure. And it introduces new readers, they want to maintain their existing credentials, and they're looking for they're working with Cypress right now as well.
Yeah, so there are adapter devices which will of various
exactly,
sorts.
And it's just another player now in the marketplace. It's another component within the system that you need to keep an eye on to make certain that they all work together. And I mean, Charles, as you mentioned, they continue working as the system ages.
All right, so
I just
last
wanted to
words,
throw out
we're almost out of time here.
Yeah, there's one word that has not been uttered in this room, and that is cybersecurity. And I just want to point out a few reasons why OSDP fits in your cybersecurity portfolio and arsenal as you're talking to customers. Is you can change the keys on the reader. So if a key is compromised, OSDP could distribute new keys to the readers seamlessly without, so walking around with config cards, if you want to piss a VAR off, just say, we got to reconfigure the readers. If you want to piss a customer off, say, we have to reconfigure the readers. Because walking to every reader, power cycling it to get it into the right mode, presenting a card, wondering if it's going to work, nightmare. It has been for decades, right? OSDP gets you out of that. So you can put new keys in a reader. You can also put new firmware. And if you just think about those two things, and in the context of any other computational environment, you need those tools to address cybersecurity threats in a timely fashion. And OSDP helps do that. So I just wanted to throw that out as another reason why OSDP can be valuable and important to you guys in speccing projects.
All right, thank you very much. I mean, we're going to be around here and we can keep up the conversation later. Thank you. Thank you, panelists.